For the record, though, it's a problem. It turns out that researchers have found that living in perfectly climate-controlled environments is one of the contributors to obesity. So we should be cold and hot all the time. So basically right now, you all are just saying. Our next speaker is Adam Dangoor, and he's going to speak now.
Hi, I'm Adam Dangoor. I'm a software engineer. I write oh no, sorry.
You need some IT people in this topic.
Great, thanks. So I'm a software engineer. I write software and docs at a startup called Cluster HQ, and we make tools for developers so that they can manage their stateful applications, and we try to document them quite well, which is a bit hard. And I'm going to talk about how you can spend your day doing interesting new work instead of really boring stuff like fixing previously working documents, so guides which are broken, which I find to be the dullest part of writing docs. So in particular, I'm going to talk to you about how you can do that by writing guides which work and continue to work over time, even as the software changes. And I think that's useful mainly because software always changes. So when you've got instructions and guides which don't work or they don't match reality, it really lowers the user's trust in your product. It makes people feel like your software is shoddy. And I know that I feel that quite a lot just by reading docs. And I guess that's because software engineers sometimes don't put docs right at the top of their priority list. And often it turns out that even in those bits of software that I think are really terrible, based just on the documentation, actually the documentation is 95% there, it's 95% correct. But maybe that's not good enough for guides. In many disciplines, 95% correct can still be really good. So here's some curtains. Here are some curtains. And what you can't tell is that the curtain pole is just a couple of degrees off horizontal. It's 95% there, and it's basically good enough. And the same with this chicken, which would have been a bit better if it had been left in the oven for just one more minute. It's close, it's good enough, who really cares? But instructions are different. If I'm following a guide and it tells me at one point to click a button which just doesn't exist on the page, or type a command which shouldn't give an error, but it does, I might give up. In fact, I think a lot of people might give up, particularly if it's like a getting started guide or something meant to sell you on the software. I'm going to assume that you've got mechanisms for writing correct documentation. Maybe after you write a guide, you manually follow it, or you watch a user manually follow it. But most systems that I've come across for ensuring that examples and instructions stay working over time are broken, or they could at least be improved. So the traditional way to keep software documentation working is to rely on three things. The first is memory. That usually means that you rely on either the software engineers who are changing code or people who are reviewing code to remember to check all of the documentation that the code they're messing with might change and then update it all. The second thing we rely on is periodic review. That means just once in a while, we go through the documentation or part of it and check that it all works, and when we find a bit that doesn't work, we fix it. And then the third way is user feedback. So some of us are very lucky to have really nice users who spot a problem and then report a bug. Maybe they file an issue on GitHub if you're open source. But all of these methods are terrible. Really terrible. First of all, that's because software interacts with other software. No software that's not really trivial exists in a vacuum. Maybe that means that the application you're writing about runs on an operating system. Or maybe it means that the application you're writing about has an explicit integration system with another application, someone else's. Things that are outside of your organization's control will change. So maybe you link to another site, someone else's site, and that third party changes their website structure so that the link you had no longer works, and then your documentation links to a 404. Or maybe you describe some interaction, some like use case of some other software in order to get your software working, and that software changes. So what you've described no longer works. The second reason this is terrible is that human memories are terrible. We don't always remember all of the places in the documentation that we've got to change. And also, when you rely on memory, you set the bar super high for new contributors. If a new contributor has to know what parts of the docs will break when they change a bit of code, then either they're going to be breaking lots of docs, or they're going to spend absolutely ages learning all the docs, internalizing them, memorizing them, before they start changing code. And that means that, say you're working for a commercial company, you might be paying people to memorize things. I think that's a waste of a salary. So, all of us, software engineers, QA engineers, technical writers, and everyone else who writes docs, has better things to do than remember how a change to a bit of code might impact the correctness of existing documentation. And we also have better things to do than periodically read through all the docs, checking that they still work and trying all the guides. What we should be doing is writing and improving documentation and features, and not just making something that used to work again. And as for relying on feedback, maybe it's okay if you're like Microsoft and you have millions of people using your betas and pre-releases, but I guess that's not most of us. And in production, people will give up on your software before even one person lets you know that there's a problem. And I don't know about you, but I don't really want people giving up on my software. I work really hard on it. So I think that there must be a better way. The first thing we've got to do, in my opinion, is abandon the myth of write once documentation. Documentation has to be written in a way which realistically acknowledges that it's going to have to be maintained, just like good code is written. So software can help to do this in two ways. First, we can write tools which tell us as soon as our docs stop working. And the second is we can write tools which actually generate working documentation automatically every time the code is changed. So in software engineering, we've got a methodology called test-driven development, which is a really big thing. It's got lots of facets, but one of the outcomes is that after every change, or maybe every minute, maybe every hour, automatic tests are run, which make sure that existing functionality still works as intended. It allows software engineers to work with less fear of breaking something which already exists. And we can also test interactions with other people's software so that we know our code will continue to work in conjunction with it. Ooh. But most documentarians don't have the same luxury with the documentation, but we can do our best. So I don't know how many people use Sphinx. I'm guessing that similar things exist in other documentation systems, but Sphinx is really good, but it will always tell me immediately when I've got a broken link. I don't have to keep going through my docs and clicking for links, or just worrying that tons of my links are broken. And it's also got a spell checker, which is nice because I don't have to worry about spelling so much when I'm writing. I can concentrate on the substance of the change, and so can the reviewer, whoever's reviewing my docs. I don't know how many people have that, but I definitely recommend code review, even for docs. But sometimes there are more complex problems than these. And those more complex problems sometimes require more complex solutions. And what I do at Cluster HQ is I write software tools which automatically test various parts of the documentation we have. And I work on a tool called Flocker, and people install that tool using the terminal, using the command line, on their laptops and their servers. And I'm going to show you first, And I'm going to show you first how we used to write things, how we used to have our Mac OS X installation instructions, which were command line instructions which use Homebrew. So here, at the bottom, that's what was outputted, that's the HTML. Just tells people which instructions to copy. And this was the restructured text. You can see it looks really similar. But what happens if someone changes the software so that it won't work without another prerequisite? What happens if they maybe make it rely on some other software? So we would have to add another instruction here. But what that person's got to do is, first of all, notice that their change might break something for a new install. And sometimes people don't notice these things. And then they've got to remember where all of the installation instructions are. So that might be that you've got this new prerequisite for every single platform we support. And that might be throughout many different places in the documentation. And then they've got to manually start a fresh machine, so it's got nothing installed already, just in case that has some dodgy interaction with what we're going to install. And then they're going to have to run the new instructions that they guess might work. And they might, again, have to do that for each operating system that we support. And then finally, they're going to have to manually change all of the install instructions and just cross fingers that they don't make any copy-paste errors or anything silly like that. And I think that's pretty common. When it's really hard to test a guide, we tend not to change it. We tend to keep it in the old, maybe not so great way. And instead, what I'd really like is to have guarantees that my guides work. And that after any changes to those guides, all the software that they're guiding you to use, those guarantees I'd like them to remain. And the current situation is that documentation is fragile. And that's because we mostly rely on the flawed human memory, periodic review, and user feedback. Our installation docs were prone to error, and the cost of improving the instructions was so high, and it was such a mind-numbingly dull task that we just didn't do it. We lived with worse and more complex installation instructions because to simplify them would have just meant a lot of work. So we tried to automate the problem away. It took some time, but this is what we ended up with. This is a restructured text. You can see it's much simpler, and it links to some Python code. And importantly, what you can see is that the output is exactly the same. After every change to any bit of code anywhere, so let's say that might be every few minutes in a working day, all of the installation instructions on every platform will be automatically tested. And that will report if they don't work, which means that we either know if new installation instructions don't work because a new change broke them, or if existing installation instructions stop working because something has changed in the platforms we support. Maybe there's a new version of Ubuntu and it just doesn't work with the installation instructions we have. We'd really like to know that without testing manually and keeping on track of what's available in the world of software. And unfortunately for everyone who writes graphical applications, it's really hard with them, but with command line applications and the command line parts of your tools, there are just a really nice ecosystem of tools that make it quite easy, particularly because there isn't so much nuance in command line interfaces as to whether some output is correct or not, as with graphical interfaces. The tool that I use is Wordish. I definitely recommend it, especially if you use Python and restructured text. So the next thing I'm going to talk about is changing the organizational model. And as was touched upon in a previous talk, there's an old model which basically involves big splash releases. Maybe once a year, a company releases a new version, they update it slowly throughout the year, and then the next year they have another massive version with loads of new features. And in that version, it might be suitable that you can write software in what's called a waterfall model, which might include, I'm writing it as a software developer, and then I hand it off to our technical writer, and they might then write the docs. But modern software won't be able to wait for that process for much longer. We're moving towards a model of continuous deployment, and that means releasing all the time. Netflix released their software multiple times a day and multiple versions of it. It just isn't feasible or realistic at that kind of intense speed to hand off finished software to a technical writer and for them then to document it. Instead, writers of the documentation and writers of the software really have to work very closely together. So if you're a software engineer, I recommend that you start thinking about writing some tests to verify your documentation's correctness. and run them alongside your unit functional end-to-end tests. And if you're a documentarian working with software engineers, then first of all I recommend that you pressure them into doing that, but also I think it's useful to work together to write documentation in a style that's testable. Some things just are inherently more easy for a software engineer to deal with than others. And the only way that I know of that this can be done is to tie the code and the docs in the same repository. So they're really integrated at an organizational level and at a software level, and that means that technical writers might have to learn Git and SVN, and I know there was a GitHub event the other day, and software engineers have to learn to only ship code, only consider code done when there's documentation to go with that software. But even better than testing your documentation, if possible, is generating documentation. So if your software generates your documentation after every change, then it's guaranteed to stay up to date. Even with the testing model, I have to see that a test fails and then fix it. Like a link's broken, I now have to choose a new link to put in its place. But that doesn't happen with generated documentation, it's pretty much perfect. And I've seen that there's another talk going to happen about API doc generation, so I'm not going to go into that too much, but I'll show an example, which is here. I wrote a Boggle solver, for anyone who knows game Boggle, and I have a class called Word, and this is all my docs, and you can see that this string is exactly the same as this doc, and if I change one, the other will change, which is really nice. But API docs aren't the only ones which can be generated after software changes. Almost anything which is like a tedious manual process, a translation from either code to copy or code to screenshots can be automated. And how this is done depends on the internals of your product usually, and sometimes it does actually involve quite a lot of custom engineering work, but what we found is that it can really pay off in the long run, particularly if testing your software is a painful situation. And so this is an example of some docs I've written, again for that game solver, and it shows the possible results of the Boggle game on this light blue background that might look white here. But then I changed my code. So I changed this blue-whitish background color to green. Now usually what I'd have to do is run the software with the input that has that same output, take a screenshot and put that screenshot into the docs. But what I've done is write a tool which automatically does that. So whenever I change what the output looks like, what the output should look like, the output in the docs changes. So you can see here there's that green backgrounded thing, which I think is pretty cool. It's early stages, but I'm working on open sourcing it, making it a Sphinx extension for anyone who uses Sphinx. So in summary, software and its documentation are inextricably linked. To improve the quality of documentation, programmers need to spend time writing docs with their code and not after, and working to make those docs continue to work. So, problem solved. Now we don't have to rely on human memory, periodic review, and user feedback. We can all have lunch. Except, wait, unfortunately, life is never, ever, ever easy. Ideally, every character of every word in our docs would be checked every minute by a robot. And we would have the equivalent of unit tests for software, but instead for our docs. We'd get the same guarantees that our docs work as we have for our software, but we're not there yet. As I've shown, there are a few tools which can help, and we can build new tools specific to some cases. We can approximate the ideal scenario, but to get there we probably need something like strong artificial intelligence. And for now, you can just catch me around and ask me how I think maybe I could help you do it. But there are things that we can do to get close, even when it's not perfect. When I can't think of a way to generate docs or specifically to test things which are outputted in the docs, I like to write a test which is paired with documentation. That means, say I've got a guide which tells some users to install my software, then run some commands, and then look for some expected output. I might write a test that does the same stuff, it does the same installation steps even if it's not actually tied to the documentation, and it asserts that the output is the same. And then I leave comments in my code and in the docs that if you change the docs, you've got to change the test. And if you have to change the test because it breaks, then remember to change the docs, which tell users, what to do. And what's really great is that can even show up bugs that a human might not find. When developers write tests, we usually write them on 3 levels. We write unit tests, which are the smallest possible piece of functionality. We then write functional tests, which are a bit higher up. We kind of see how bits of our software work with the other bits. And then, if we're really good and put the time in, we write end-to-end tests, where we guess what a user might do, emulate that, and check that our software works. But when you're writing a test that's actually linked to a guide in your docs, you're making sure that your docs work, and you're making sure that your software works in a way that we expect customers to use it, or users to use it, instead of what that one developer, that one time, thought a user would use it. This is really testing how you're telling people they should use it. So what we did is we tried to make a guide for running Elasticsearch on Flocker. Flocker is our tool. I don't know if any of you have heard of Docker, but it's something that works on top of that. And Elasticsearch is a log searching tool, usually. So people put their logs in it, they mess with them, and then they see data about those logs. So what we did is we wrote a guide that basically told the user to put some logs in Elasticsearch on top of Flocker, play with Flocker, and then check that those logs still existed. And we wrote the guide and we manually ran it. And it was really great, it all worked, and it showed how wonderful Flocker is. And then what happened is we wrote our automated test that was linked to that doc. And it did exactly the same and broke. It gave us an error. And what turned out was that we were running it slowly. We were running it really methodically, in order that we would just make sure that we're copying and pasting the instructions perfectly, and we're seeing the right output, and we're ticking off checkboxes. Yep, it works as expected. But the computer doesn't do that. The computer runs really fast. And it turned out that if you ran our guide fast, then you would see an error, because something wouldn't have started up in the stack before something else. It's what we call a race condition, when software depends on one thing finishing before another, and that's not always guaranteed that it will. So we found a bug that a human wouldn't have found. We found that a fast user would really suffer. And that's a bit early, sorry about that. I spoke faster than expected. Maybe I'm just a bit nervous, but thank you very much for listening.
Congratulations, you get to go to lunch early. So we'll be a little bit longer on lunch, like, 5 minutes longer, enjoy it. And then we will resume with lightning talks at 1:40, yeah, 1:40 p.m. So be here in your seats by 1:39.